I'm back here on Code Composer Studio, and I'm going to create a new project. So this time I'm going to call this project the OLED button and OLED project. Let's select our debug probe. Let's select our target board. So it's the C505. Let's check that there is no there is this correct runtime support library. Also, we will have an empty project. Okay, so it will create this folder in the workspace. Now we can extract these files from the example folder, and we are going to extract to our workspace the LED button OLED. Okay, so let's extract. So now we have here our project. Let's just check the important properties. So we need to check if the correct board is selected. We need to check if the debug probes selected. I will not use the link file now. We need to check that the memory is set to huge, and also that the runtime model options is set to 32. So everything seems to be fine. We can try to build a project to see if everything is fine. So we have here our console window. So build finished, no errors. So we can start to look what we are going to do in this example. Now we have our files here. We check the properties and we can start our example. So in this example, it's still a audio loopback from input to output, but we will have a kind of state machine that will have three states. One state is no processing at all. Then we press a button, and then it goes to the next state, which is we are going to convert stereo to mono. And then we press a button and we go to the next state, which is we are going to play what's in the left input to the right output, and what's in the right input to the left output. So we are changing left to right from input to output. So we can check here our main file. We are going to use this includes. So we are including a function for converting mono to stereo. We are using push buttons. We are using the OLED. This is for future use. We're not doing a bar graph now. We're not using any DSP processing now. We will use PLL. We use the audio codec, and then the LEDs and the GPIOs and things from the USB stick 5515. Here we are defining the variables for left input, right input, left output, right output, mono input. Is the same what we did in our previous example. We are going to use 48 kilohertz, so we're defining here the samples per second. Here you can adjust the gain. So if you're using a line input, you can set a very small gain or no gain at all. If you're using a guitar, you can set to 20 dB, or if you're using a microphone, you can set it to 30 dB. Here we're defining some steps. So for example, we can have many different steps. And here we are defining this integer that it's used to go through the samples and read and write from left and right from the audio codec. So again, it's very similar to what we did previously. We have this function to initialize the board. We set a PLL frequency of the processor. We initialize the audio codec and the I2C for the audio codec. We also initialize the 4 colored LEDs. We've seen how to do this. We've seen this function, which is the initialization of the LEDs. So we set the direction to output, and also we turn off our LEDs. This is what we're doing here. Then we are also initializing the OLED. So we've seen also this function. So we configure, we enable the I2C, we set contrast, we set the different configurations, the different voltage clocks and everything to start using the OLED. Here is for the SAR ADC, so we are going to use the push buttons, and we have this initialization. So then we are going to display an empty message. So this is the OLED display message that we've seen before, and here you can see that there is 16 characters and 16 empty characters, so it will be a blank display. Then we will print that we are running our project for the LED, the OLED, and the button. So is the audio loopback. Here I'm just displaying also some message. So it's the Guitars AI tutorial 4, and then we are waiting. So you can see, and then this is some instructions that will be placed in the console. So you can press switch 1 for down, switch 2 for up, switch 1 and 2 at the same time for reset. And we have these 3 steps. Step 1 is no processing. Step 2 is stereo to mono, and step 3 is left input to the right output and right input to the left output. Here again we've seen that we are setting this XF LED off, and now we are going to loop through and start reading from the audio codec. Here we are converting stereo to mono, and we are placing this into this mono input. So if we want to use this, we have this stereo to mono. So this stereo to mono is this simple function that basically we are adding the 2 channels and then dividing by 2 to prevent the overload. So now we are in step 1. We save this step to this function. It's called the push buttons read. So in this push buttons read, we give the number of steps we want to have. So this is the maximum number of steps. So we're using 3 steps, and then it will read the state of this analog input, and then it will say if it's the switch 1 was pressed, if switch 2 was pressed, or switch no switch is pressed, and then it returns this value. And we've seen before here how to do the bouncing. So this is exactly what you're doing here, and this push buttons read will give us the state. So it's not the steps. So it's not the state of the push button, but it will read, and then it will give us the steps, because we can loop through. So if we're in step 1, and then we press up, and then go to step 2, and then we press up, and then we press up again, we'll go back to the first step. So here we are doing, if we are in step 1, so the step is the return from this function here, then we will do no processing. So here I am also setting an LED to display that we are on step 1. So for each step we have a different LED that's going to be with its light on. On step 2, here we have already the stereo to mono, so the left output and the right output gets the mono input, and here we have this OLED display, and also we set another LED. And finally we are in step 3, and then we are just changing the left output gets the right input, and the right output gets the left input, and we have here this OLED display message. So step 3, left to right, right to left, and then here is the same like the previous example what we did. So basically we are using all these functionalities and components of our board that we've seen. So we are using push buttons, and we are using this way here to loop through different steps. So we can also use these push buttons read raw that will tell us which button was pressed but not which step we are in. So this is just a way to loop through steps very easily. And this is what we have now.